I'm Mallory Glenn, and I will be teaching the slope of the tangent line. In order to find the slope of the tangent line, you will use the equation the limit as h approaches 0 of f of x plus h minus f of x all divided by h. And the equation for the tangent line is y minus f of x1 equals m, which is the slope, times x minus x1. So the example will be as follows. The given equation or function will be f of x is equal to x cubed minus 2x squared plus 4 with the point of 3, 13. So you would first start by solving the slope, which would be the limit as h approaches 0 of f of x1 plus h minus f of x1 all divided by h. Your x1 will be 3, which you can find in the given point, and the f of x1, which is the y value, would be also come from the point, which would be 13. So you'd plug in 3 and 13 into the respective places into the formula, and you will have the limit as h approaches 0 of f of 3 plus h minus 13 all divided by h equals the slope. So you would go back to the original equation, which was given, and you will have f of x equals x cubed minus 2x squared plus 4. But instead of finding f of x, you will then find f of 3 plus h. And you will have 3 plus h cubed minus 2 times 3 plus h squared plus 4. So when solving f of 3 plus h, you will end up with h cubed plus 7h squared plus 15h plus 13. And you will plug that into this equation. And so you will have the limit as h approaches 0 of h cubed minus 7h squared plus 15h plus 13 minus 13 all over h. So once you subtract the 13s from each other, you will end up with the limit as h approaches 0 of h cubed plus 2h squared plus 15h divided by h. Now when plugging in 0 into all of the h places, you will end up with 0 over 0 as your answer, which is not possible. So in order to avoid that from happening, you will have to factor in h out of the numerator, which since all of the terms include h. And once you do that and cancel the h from the numerator with the h from the denominator, you'll be left with the limit as h approaches 0 of h squared plus 7h plus 15. So from that point, you can then plug in the 0 into each h in the function, and you will end up with the answer of 15 for the limit as h approaches 0.